Hello everyone. So now we are going to look the high availability technique. This one we are going to do high availability techniques such as redundancy, FHRP and SSO. This is a theory and also here we have the configuration also. So this we are going to do. Let me show you the configuration. They mention two times. One time they give the theory and another time they ask the configuration. FHRP also they ask here. So let me check where we have that one. FHRP. This one. So let me highlight this also. So in this one what we are going to do, we are going to look the redundancy protocol and how we can configure. After this we are going to look the interVLAN. Then we are going to do one lab. We need to have the big lab, that is real scenario we are going to do. Real scenario we need to know interVLAN, we need to know HSRP, we need to know VLANs and NAT, network address translation, that is PAT we are going to use. So anyhow we will see, I am planning that one, we can do that one, but anyhow let's start first HSRP. In HSRP we are going to discuss about what are the advantage of using this one, what is the HSRP, all that one we are going to look. So if you see here, first of all, what is redundancy? Redundancy we need to know because they are asking redundancy protocol. So let me show you one example here. Redundancy we are calling failover, high availability, clustering, RAT, fault tolerance. In simple words, redundancy means we need to have the backup of device, maybe backup of link or backup of power supply, backup of the router, any backup. Example, if you see this one, redundancy power supply, I can say here, redundancy power supply, because I have two power supply in this device. If you see, this is one power supply, here is one more power supply. So we will apply both power supply. Device is working on one power supply, other power supply will be standby. If anything happen to this power supply, our device will not go down, it will work on the other power supply. That is known as redundant power supply. If you look the other example for the redundancy, this is the customer edge, we are calling this is a customer edge, and we have the ISP1 connection, ISP2 connection. We have two ISP, that is ISP1, ISP2. So if this link go down, our internet, our data, whatever our end user is working here, their work will not stop. If this link go down, the traffic will move to the second ISP. So what we can say, this is a redundant link. This is redundant link. First one we saw redundant power supply, redundant link. And if you see, this is a RAT, we are saying RAT configuration. What we will do, we will configure the hard disk in the servers. Nowadays all server is having this configuration. So automatically the same replica of one hard disk will store in another hard disk. If we have any one hard disk fault, any one hard disk go fail, just we can remove and we can put the brand new hard disk. Automatically it is going to get the backup of other hard disk. So this one also we are using in the server field. So this is also we can say redundant backup, that is redundant hard disk we have in this. So what we are saying, that redundancy is nothing but failover, high availability, clustering, RAT, fault tolerance, all this is nothing but redundancy. A good network design provides the redundancy in the device and the network link, because nowadays no one need the downtime. Nowadays no one need the downtime, everyone need all the time devices are working, every time link will be up, we should not have the downtime. Nowadays everyone need no downtime, zero downtime. So what we will do, we will use some redundancy technique. We can use the ether channel for redundant link, we can use the high availability HA in the what we can say, if you are using the firewall ASA or Palo Alto, we can do high availability configuration between these two firewall. Example, if you have the firewall one here and you have another firewall, we will connect this one and we will configure the high availability. This is our LAN network in this side, here we will connect it to WAN. So whatever configuration, whatever traffic we have, that will be copy we will have in the other firewall. If this firewall have any issue, our traffic will move to this firewall. Okay, that depend configuration to configuration. We don't have firewall in our syllabus, but we need to have the idea. Redundancy is also known as failover. It is also known as high availability, or we can say clustering, RAT configuration for the hard disk, and the fault tolerance. So why we need this one? Because we don't need the downtime. And redundancy basically can be hardware or with the software also we can say, and we can use the backup. In simple, redundancy means backup link or backup hardware or backup software or backup router we need to have. So if one go down, automatically other thing will stop, and we will not have any downtime. Okay, so let me show you one network design here. This is the network design. This is a small organization where we have the one router. Imagine this is a ISP router. Okay, this is a ISP router, and this is our company router gateway, and this is our switches and our devices. They are communicating to internet. If our router go down, we will have the issue because we don't have redundancy here. We should have the redundant router. We should have the two router. If one router go down, other router should start, and we should have the two ISP. But here we don't have. We have only ISP. So this design is not good design. We can say this is not a good design because we don't have redundancy in this one. So what we can say, if we want to design a good network, what we will do, we will use two ISP connection. If you see here, we will use the two ISP connection. This is the gateway 1, we can say this is a gateway 2, and we have the ISP 1 here, we can say ISP 1, and here I can say another ISP 2. So our traffic will go here. If anything go wrong, our traffic can go from here. So that is nothing but FHRP. So we will see how we can configure what we will have. We are going to look that one. First we will do some basic labs, so you will have more idea. Now we have idea about the redundancy. Already we have this topic in the CCNA. Basic overview, we finished. Now what we are going to do, we are going to do some basic lab. After that we are going to look the VRRP also. VRRP we don't have in the CCNA. HSRP we have. So first we will do HSRP, then we will go for VRRP. Okay, so let me do one basic lab. So with that one you will have the idea. I will design one basic lab, and I will show you what issue we can face and how we can fix with the help of what we can say with the help of HSRP. We are going to discuss that one. So what I will do here, I will take router. Imagine this is our one router here and another router here. Let me make zoom in this one. Okay, let me make zoom in this. What I can say, I am designing the small organization structure. This is the enterprise network. This is a basic drawing, basic topology. Later when we finish this topic, we will look the complex topology. Maybe after 2 days when we finish the other supporting topics, we will do one basic lab. So with that one you will have the idea about the real enterprise network, how they are working. We will not use firewall, but in real scenario you will get the firewall also. Okay, but the concept, everything will remain same. So anyhow, what I done here, I taken one switch, I taken two switches, we connected with the two gateway. We can give the name gateway 1, gateway 2. I will read GW1 and this is a GW2. Gateway, this is the edge router. Edge router means the router which is connecting to the ISP. The router which is connecting the LAN network to WAN, that router is known as edge router. Okay, so I can take two PC here, or n number of PCs you can take, no issue. You can imagine I am using here 4 PC. You can imagine in your organization you have 400 PC. Okay, so now this is a small enterprise network I am doing here. Imagine this is a what we can say core layer. This is a distribution layer, and we will have the access layer, but for this lab purpose I am using directly. Imagine this is a 2-tier architecture. Okay, this is a distribution as well as the core layer, and this one is the access layer. Imagine like this scenario. So now we will have the ISP here. I will give ISP1 here, and here I will say ISP2. ISP means internet service provider. So in our organization we taken the internet connection from the two ISP. In our organization, we taken the internet connection from the two ISP. We can say ISP1 as a primary ISP. Primary means the actual ISP which we are going to use. And this will be the ISP2 will be the secondary ISP. Secondary ISP means backup link. Backup link we can say, backup link we are saying secondary ISP. Okay, so whenever we have any issue with the ISP1 or any issue, we can use the ISP2. So this is our situation, this is our scenario, which one we are going to do now. Later we will have one more layer and we will have that we can use the DHCP server to get the IP. We will use the inter VLAN, that is switch virtual interface, to make the communication with different VLAN. Now I am using only one VLAN, that is VLAN 1. Whatever we have by default, we are using that one in this scenario. In the coming classes or maybe after 2-3 lab, we are going to use the 3-4 VLAN 10, 20, 30. We are going to make the communication between different VLAN by using the router on stick or SVI, that is the interVAN technology we are going to use, and also we are going to get the IP from the DHCP server. Not manually, we are going to do in the coming classes. Okay, but now here I will give manually, so you will have the concept is important. Later you can play. Okay, later you can play whatever you want. So what I will do, I will write here, I will imagine we have the Google server here, so I will write 8.8.8 here, and here also I will write 8.8.8.8 Google server, and let me draw some line here. So we can say this is a ISP. Okay, this is a ISP and he is giving the internet to us, we can say like this. So I will move this here. Imagine we have the ISP here. Let me write here ISP1 here, our primary ISP, and this is a secondary ISP. I can say ISP2. Okay, ISP2. This is very important because we are going to do 2-3 labs based upon the same scenario. We will do little more deep. So if you understand this, you will get other lab also very easily. Okay, so this is ISP1, ISP2, and here I can assign any IP, whatever IP I want to use. Example, what I will do, let me make little zoom also so you can see the screen clearly. I hope this is clear now. So now here what I will do, this is a LAN network. We need to remember, in interview you will get the question also. In interview they will ask you HSRP is a LAN technology or WAN technology. Okay, LAN or WAN. In interview you will get this question also, LAN or WAN. LAN or WAN. So you need to remember this is a LAN technology. HSRP is a LAN technology, not a WAN technology. This is very important question. Many of my students get this question, so try to remember this one. HSRP is a LAN technology, not a WAN technology. Okay, HSRP is a LAN technology, not a WAN technology. So what we are going to do, we are going to apply the HSRP in our LAN network. So if you see, this is our LAN network from here to here. From here to here, this is our LAN network. From here to here, this is our LAN network. And if you see this side, this is a WAN network because this one is connecting to the ISP. Okay, this is connecting to the ISP. So we can say this is a WAN network and this one is a LAN network from here to here. So remember, HSRP is a LAN technology. In LAN technology, we can design any IP whatever we want. Okay, as per our wish, we can give any IP. We will use private IP. I will give 192.168.1.1. Okay, let me give 1.1 here. Okay, and this interface I can give anything 1.2. We need to use the same network IP for this HSRP configuration. And I will give here one more IP, that is 1.3. We are going to discuss the theory. No need to worry about the theory. Here I have the theory. I will give you what is the HSRP, what we can say, different types of HSRP, that is VRRP, GLBP. We are going to discuss what is the difference and what all that one. But before going to this topic, first I am showing you some scenario. With that one you will have the idea. You will understand the situation easily. That's why I am doing this lab first. Then we will look for the theory. So what we are saying here, this is the IP we are going to assign to this interface. This is the IP we are going to assign to this interface, and this will be our logical IP. How this is how logical, how we are getting, we are going to discuss this very soon. So now I will assign the IP here. Let me write the label here, some label. I will write 192.168.1.4. Okay, 1.4. I am taking 1.4 because I already use here 1.1, 1.2, 1.3. I reserve for HSRP. So I will take 1.4. I will assign here inside this one. And gateway we need to give. Generally, what we will do, we will give the gateway as a router IP. If you see, I have the router IP here 1.1, or I can use 1.2. Okay, I have 1.1 or I have 1.2. So I have two options. I can give this gateway or I can give this gateway. Let me give any one gateway now. Later we are going to see. So this is the gateway I give this one to my machine. Okay, so I will assign the IP here also 1.5. Any one PC we can assign also just for lab purpose, testing purpose, but anyhow I will assign to two machines. Now what I will do, I will give this is also 1.1. So what I am saying here, let me repeat again. This is the machine, that is my PC. I give this is the IP of my machine, and I give default gateway as this one, this IP as a default gateway. So all my traffic is going through this router. Okay, so all my traffic will go through this router. Let me do the basic configuration to the router so we can ping and we can check that one. Let me take the notepad. I will write the basic configuration and we can start working on that one. Our device can access the internet. Then after that we will look what issue we are going to get. So let me write here HSRP lab. Okay, basic lab. So R1 configuration. R1 configuration is enable config T host name. We can get gateway 1. Okay, the R1, that is router 1, is known as gateway 1. And then we have the interface fast Ethernet 0x0. We will give IP address 192.168.1.1. okay, 255.255.255.0, and we will write no shut. This is the one interface, and we can design, we can create one loopback 0, and we can give 8.8.8. so we can imagine that is nothing but internet. Okay, so I will give this one. I hope you already know this one, we done before, loopback interface. So this is a R1 configuration, that is gateway 1 configuration. I can write here GW1, gateway 1 configuration. Now we can do the configuration for the gateway 2. Gateway 2 means router 2, this one. So here I will make this is a 2 and this also 2, and this one we selected the IP as a 2 here and here. Okay, and here also we have the internet, that is 8.8.8. So let me copy and paste this configuration in the R1. I will copy paste in the R1 here in the R1 CLI. Let me write here no, and then I will paste this configuration here. So everything is good, no error, nothing. And let me copy the second gateway configuration and paste in the second gateway. That gateway is nothing but second router. Okay, so now let me paste that one. So everything is good here. What I will do now, I am going to try to ping the internet. Let's see I can access the internet or not. First of all, I will check what is my IP. So my IP is 1.4 and my gateway is 1.1. I will write here ping dash T hyphen T. Hyphen T means continuously they are going to ping. Okay, hyphen T is this one. Okay, see here what I am saying, this is the ping hyphen T 8.8.8. Why I use hyphen means it is going to ping continuously. If you do normal ping, it will have the 4 packets, but now you are getting continuously. So our traffic is going from this direction. Our traffic is going from this side. Okay, this side to this side. We have two ISP connection, ISP1 and ISP2 here. We have two internet connection, ISP1, ISP2. And now we send the traffic is going from here. Imagine if this ISP is having any issue. Okay, so what I will do to create the problem, I will make this interface F0x0 as a DON. So what I will do, I will go here inside that interface, I will write interface F0x0. I will write here shut. Okay, I make this interface done. So now let's see our traffic is going or not. Okay, if you see, we have the request timeout, we have the request timeout, we have downtime, our internet is down now, we are unable to access. We have two ISP connection, but when this link go down, we are unable to access. Even if you have the two ISP, even if you have the two ISP, two internet service provider connection, when this link go down, ISP one link go down, you have the downtime, you don't have the internet. So what you will do in the real scenario, maybe you can go and change the gateway of this one, right? Because this is the gateway. Okay, if we want to send the traffic from the gateway 1, we can set this IP in our all machine as a gateway. But if we want to send the traffic through this gateway 2, we need to set this IP, the interface IP, that is 192.168.1.2 as a gateway. We need to set this one as a gateway. Now we have only 4 PC, you can easily change the gateway. Imagine if you have 500 PC, 2000 PC in your organization, how you will change? You will go and you will change. It will take maybe one day. Go one by one to all PC and change the gateway. Okay, it is not practical. You cannot do, and you cannot call the guy and say that HR guy, can you go to the CMD or can you go to the control panel, look the adapter and right click that one, select the IPv4, change the gateway as this one. They don't know anything about this one. Many guys from HR, finance, they don't know anything about the what is gateway. They don't know what is IP also. We cannot ask them to change this like this way by calling saying that our ISP 1 is down, so please change your gateway from 192.168.1.1 to 1.2. We cannot do like this. Okay, we need to manually go and change, or we can use the HSRP. So what we will do, we will use the HSRP. So automatically our traffic from here to here, it is going to switch to this side. Automatically our traffic is going to switch from the gateway 1 to gateway 2. When this link go down, automatically our traffic will switch from the gateway 1 to gateway 2 with the help of HSRP. Okay, we can use HSRP, we can use the VRRP, we can use the GLBP, depend company to company. Mostly we are using HSRP. Okay, so now we understand what is the problem. What is problem? We have the problem whenever we have the ISP down, ISP 1 go down, our traffic is not moving automatically to the ISP 2. Okay, so what we are saying, we cannot move the traffic from the ISP 1 to ISP 2. If we want to move the traffic from ISP 1 to ISP 2, we need to change the gateway. That is a default gateway. In all machine, we have the more than 2000 computers, machines in our organization. We cannot change. To overcome these types of issue, we are using the HSRP. So when we use the HSRP is going to do automatically, is going to redirect the traffic. So what we will do in this scenario? In this scenario, we assign this one as a gateway in our machine, right? So we are saying if this go down, we need to assign this one. So what we will do, we will not use this IP, we will not use this IP. We are going to use another IP. This IP we reserve for the HSRP, so we are going to use this IP. So we are going to assign this IP as a default gateway in all machine. This IP we are going to assign as a default gateway in all machine, and whenever we configure the HSRP, this logical virtual IP will be available this side. If this link go down, automatically this virtual IP will move here with the virtual MAC address. So we are going to see that one, how we can do, how it will come, we are going to see that one. Just I want to show you the practical scenario, what issue we will face and how we can fix this one by using the HSRP. Configuration we will see, and all the scenario we are going to see now. So before going to the configuration, let's discuss some theory topic. Here what is HSRP and all this one. I hope now you have some basic idea. Redundancy we already discussed, and this scenario, just now what we design in the packet tracer, this is a scenario. One will be active, the gateway, other gateway will be standby, and we will have the HSRP IP. We are going to assign that IP in our machine as a gateway. Redundancy we discussed, that is fault tolerance, and the ether channel we can configure to do that one. already we discussed. So let me discuss here. First three, what we can say, there are three first hop redundancy protocol. Okay, there are three protocol. We can use any one depending upon our requirement, which one we want to configure to use this redundancy protocol. First hop redundancy protocol. What is meaning of first hop? Means the next hop. Example, if you see here in this scenario, first hop. So here this is our first hop. So first hop redundancy protocol. So we need to have the redundancy. If this go down, we should have other thing to be ready. That is redundant device, redundant gateway. So we are using first hop redundant gateway. In this category, we have three types here. If you see here, first one we have the HSRP. First one we have the HSRP. HSRP stands for Hot Standby Router Protocol. This is a Cisco proprietary. It will work only in the Cisco device. And second one we have the VRRP, that is Virtual Router Redundancy Protocol. It is a open standard. It is very similar to HSRP, only the difference is it is open standard, means you can use this in the other vendor devices also. Not only the Cisco, you can run this device in the Hawaii and whatever the other routers like Nokia or other vendor devices also. And we have the GLBP, that is Gateway Load Balancing Protocol. This is also Cisco proprietary. And what is the difference here between HSRP and GLBP? Means in HSRP we cannot do the load balancing, but the GLBP support the load balancing also. In our syllabus we have only these two, so we are going to look these two. In CCNA we have only this one, but in CCNP they put this VRRP and the HSRP both. If we see in our syllabus paper, they mention the both here, HSRP, VRRP. So we are going to see that one, how we can configure. We need to remember HSRP is a Cisco, it will work only in Cisco device. VRRP only, not only Cisco, it is a open standard. So how it is going to work, just now we discussed how it is work. How it is going to work, we just now we discussed, like whenever we have this scenario, he is going to have the logical IP with the logical MAC address, and all traffic is going through this one. If this router or link go down, that logical IP and the logical MAC address will move to here, and all our traffic will go through this one. The guy who is working this one, that guy will be active, the other guy will be standby. So we are going to see that active and standby also. So one guy will be active, another guy will be standby. So let's see first of all some theory about HSRP. Okay, so let me move this in next page only here. So if you see here, HSRP, Hot Standby Router Protocol. This is very important. In interview you will get some question from here also. So it is good if you remember, you need to remember the full form also. HSRP stands for Hot Standby Router Protocol. Some guys are saying routing protocol, but the correct thing is a router protocol. HSRP stands for Hot Standby Router Protocol. It is a Cisco proprietary protocol. It will work only in the Cisco device. We have two versions here also, version 1 and version 2. We are going to see what is the difference between them. One is supporting IPv6, one is not supporting IPv6. But now remember, we have two versions. Two or more Cisco router or switch on the LAN segment from a HSRP group. See, this is a key point, LAN. This is a LAN technology. HSRP we can configure in the LAN technology. And what we are saying, we can use the layer 3 switch, or we can use the router also to do this configuration. Okay, we are going to see the layer 3 switch also, how it will work after some time. And now we will say, when we configure this one device will become as active and other device will become as a standby. So now maybe you will have the question, which one is going to become active and which one is going to become the standby. So first of all, here they are going to look the priority. Here also we will have the priority. In the HSRP, higher priority gateway is elected as a active gateway. So first what we are saying, one gateway will become as a active, other gateway is also going to become the standby. If you see this scenario, let me show you here in the packet tracer. this guy is going to become active. Example, this guy is going to become as a standby. So how only this guy will active and how this guy will be standby means, first they will look the priority. Whoever is having the higher priority, that guy is going to become active, and whoever is having the low priority, that guy is going to become as a standby. But by default, all the devices in the Cisco is having the priority 100. If priority is same, then they will look the highest interface IP. This interface, this IP is 192.168.1.1, this IP is 192.168.1.2. so this guy will win the election and he is going to become the active. If you want to make this guy as a, what we can say, active, you can increase the priority. We can increase or decrease the priority. Okay, so what we can say here we can say, first they will look the priority. Whoever is having the high priority, that guy is going to become as active. An active gateway own the virtual MAC address and virtual IP. So they are going to get the virtual. Whoever is having the active, we are going to get, that guy is going to get the virtual MAC address and the virtual IP address. And by default, we have the priority is 100. As I told, by default, all the Cisco devices having the priority 100 in HSRP. But we can tune, we can change from 0 to 255. If you want to increase the priority, example, your manager told you, example, imagine when you configure the HSRP, this device become as a active. Okay, this device is become as active. So your manager told you this is a old router, this is a new router, and this router is having good configuration. So try to make this guy always active. So what you will do, you will increase the priority here. You will increase the priority of this router. So always this guy should be active. If anything go wrong, then this guy will become active. Okay, so what we will say, we need to remember that if we want to make the active any router, we can make with the help of priority by increasing the priority. If priority match, both are having same priority, then they will look the highest interface IP. Okay, and we have the prompt option. Prompt means they are going to check. Example, if let me show you. Example, when we configure this one, imagine when we configure, imagine I configure this guy as a active, or just I configure the HSRP, this guy become active. Okay, because he is having the high IP address, this guy become active and this guy is a standby. And example, this router reboot or maybe this link go down, so this guy will become active. And later when this guy come, he will not become active, he will become standby. So what we can do, we can enable the prompt command. If we enable prompt here, both sides, they will sync, they will check, they will compare again the priority and the interface. By default, prompt is off, prompt command is off. Prompt means like whenever they both are up, they will synchronize the priority, they will check the priority and they will check the highest interface IP. If I did not enable the prompt command, example, this guy is active. Okay, imagine scenario, this guy is active, this guy is a standby, and I reload this router. When I reload this router, this guy will become active. Okay, and when this guy come up, he will become standby, and the scenario will go like this only. But here this ISP is a low speed and this ISP is having good speed, so we need to make this guy as active. So we increase the priority even though this guy is active. So what we need to do, we need to enable the prompt command. When we enable the prompt command, both are going to sync and they will check and they will compare, and whoever win the election, they will make that guy as a active. So prompt option is disabled by default, we can enable that one also. And if we see in the HSRP 1, we use the multicast address 224.0.0.2 for sending the hello traffic, and whereas in HSRP 2, it used the 224.0.0.102, this IP, multicast IP, for sending the hello packets. And HSRP is also having the authentication, it support the authentication in the clear text or MD5. This is an authentication technique, message digestive 5, MD5, we can use MD5, this is more encrypted one, or we can use text. Now just remember, it support the authentication, means we can put the password. We are going to do lab, so you will have the more idea about this one. So now what we are saying, HSRP is supporting the HSRP is supporting the authentication, so we can put the password. Then we have the HSRP version 1, version 2. They have the group number range from 0 to 255, and if you configure the version 2, we will have the 0 to 4095. If you have more devices, you want to configure more group, we can use this one also. Okay, and if you are using IPv6, then you can use the group that is version 2, because version 2 only supporting the IPv6. Version 1 is not supporting the IPv6. If you see, HSRP version 2 support IPv6, whereas HSRP version 1 does not support IPv6. Whenever we are using version 1, this is a default MAC address we will get. This is a logical MAC address 000.0c07.ac // whatever group number we use. Example, I use group number 10, so here I will have the 10. If I use group number 1, we will have 01. And if we are using the same thing here also, this is a MAC address 00.0c9f.f3 number. This number will be the group number, whatever group number we taken. When we take the range from this, we will have that group number in that MAC address. And HSRP, this one we already told, like IPv6 it is supporting. And HSRP version 1 and version 2 are not compatible, means you cannot configure one router as a HSRP 1 and another router as a HSRP 2. If you are configuring here 2, you should configure here also 2. If you are configuring version 1, here should be version 1 only, not the 2. Okay, and version 1, version 2 default hello timer will be 3 seconds. Important, in interview you will get question, remember this. 3 second hello timer, hold on time is 10 seconds, and by default the priority will be 100. So this one we need to remember. Okay, this theory we need to remember what we are saying. 3 second, 10 second, and priority is a 100. HSRP also having the state, like initial state, initial, listening, speaking, standby, active. These are the 4 states we need to remember. First we have initial, 5 state total. First we have the initial. When we have the initial means beginning state. Initial state indicate the HSRP does not run. When we did not configure, we have this state. Then after that, when we start configuring that one, the router know the virtual IP. When we configure, we will get the router will go in the listening state, but router don't know who is active and who is standby. Okay, they are listening the hello message. Then we have the speak state. The router send the periodic update, that is hello messages actively, and they will have participate in the active or standby election. Here they will do the election in the speak state. And if we see standby state, in this one, router did not become active router, but will keep sending hello messages in the standby. In active, they become the active, and here they will receive and they will forward the messages. So just remember, we have the 5 state. First one is the initial, listening, speak, then standby and active. So these are the state. This is a theory about the HSRP, basic introduction about HSRP. What is and also redundancy. What is redundancy? Redundancy power. Redundancy means having more than one. If anything go wrong, other thing will work. Maybe it can be, we can say maybe redundant power supply, maybe redundant link, maybe redundant hard disk, or we can say redundant link also, or redundant gateway also. If you see here, here is a redundant gateway. Here we have one gateway here, one gateway here. So we can say redundant gateway also. So this is a small introduction about the FHRP. Let me stop this.